Today we're going to look at multiplying integers. And so real quick, I just want to kind of stop and think about what does it mean if we're multiplying. So let's think about 4 times 3. And I'm going to use my integer counters here. The 4 means that we have 4 sets of 3. So if I'm looking at my integer counters, there's a set of 3. There's a set of 3. Another set of 3, and then let's put one more set of 3 on there. So I have 4 sets of 3, okay? And when I go and find what that is, that gives me 12, okay? Okay, so if I then decide to look at 4 times negative 3, it means I have 4 sets of negative 3. So there's a set of negative 3. There's a set. There's a set. And then we have one final set here. So we have 4 sets of negative 3. And so you notice they're all yellow, and there's 12 of them. So we end up with a negative 12 there. Now, we're going to start looking for some patterns in this because there are some easy ways to think through this, and I'm going to show you 2 of these. Okay, so let's think about 3 times negative 3. Okay. Let's just go ahead, I'll just draw it out. If we have 3 sets of negative 3, I want 3 negatives. That's the one in parentheses, and then I want 3 sets of that. And so when I get finished there, I end up with 9 negatives. So negative 9. Okay. On the next one, it says 6 times negative 2. So we have 2 negatives, and then we need 6 of those sets. So there's a picture of that. And then when we notice there, we have 12 negatives, or negative 12. Now for our last one, we have 5 sets of negative 1. So here's my negative 1, and there's my first set. Now I need my 5 sets. Okay. And when I look at that, I end up with a negative 5. Okay, so now let's take this one step further. If you think about it, if I say, let's look at our first problem that we did up here with the 4 times negative 3. Okay, when we go to do any multiplication, okay, if we know that 4 times 3 is 12, then we know that 3 times 4 is 12. So if we switch those 2 around, we're still getting the same answer. So a negative 3 times a positive 4 gives us a negative 12. All we've done is switch the location of those. So as I look at the problems that I drew, if I have 3 times negative 9, or sorry, 3 times negative 3 gives us negative 9. If I switch those 2 around, I end up with negative 3 times 3. I still have to end up with the same answer of negative 9. Okay. Well, on my 6 times negative 2, giving me negative 12, if I switch the 2 numbers around, I have negative 2 times 6. I still have to end up with the same answer, which is negative 12. And then on the last example here, if I switch the 5 and the negative 1 and do negative 1 times 5, I still have to end up with the same answer there. So let's look at our last thing that happens here. And this one's a little bit trickier to see. Okay, if I have negative 3 times negative 3, I'm going to cover up this negative real quick, and I'm going to say, okay, I have 3 sets of negative 3. So there's a first set. And this is the part that it gets tricky, but if you think about it, if I've got this negative out in front here of my 3 sets of -3, really all I'm doing is saying I want the opposite of this, or I want -3 sets, which is kind of hard again to think about. So all that you're really doing is you're doing the opposite of what you just had on there. And so what you actually end up with is +9 there. Okay. Okay. So if I look at my -6 times -2, I'm going to ignore this negative out in front, and I'm going to think, okay, I have my 6 sets of -2. There's my 3rd set. There's my 4th set. There's my 5th. And one more. So if I have 6 sets of -2, and then I pay attention that I have a negative out in front, it says, well, I actually want the opposite of what I have right there. So I'm going to just flip over my integer counters that I have, and I end up with a +12. Okay. And then on my last one here, the -5 times -1, if I cover up the negative on the 5, it says I have 5 sets of -1. So there's 2 sets, 3 sets, 4 sets, and 5 sets. And the negative out in front says I actually want the opposite of that. Okay. And so we end up with a +5 there. Okay. Now again, to me that's the trickiest part on this. But let's go ahead, let's see if we can get some rules established here. Okay. I want you to think about if I added on here and I just said, well, I have a +3 times a +3, that would be +9. Okay, if I said a +6 times a +2, I have +12. And if I have a +5 times a +1, I get a +5. So if we look at these last 2 rows here, I'm just going to circle them. Kind of more of a weird shape, but anyway, you will notice that when I multiply 2 positives together, I get a positive answer. You will also notice that if I multiply 2 negatives together, I get a positive answer. Okay. And so that's those are our first 2 rules, that if you're multiplying 2 positives, you get a positive. And if you're multiplying 2 negatives, you get a positive. Okay. Now, if you have one of each, okay, which is what we had up here in the examples that I drew. Okay, if you have 1 positive and 1 negative, you get a negative. Well, if I have a positive and a negative and I switch them around, I still get a negative answer there. So a negative times a positive gives me a negative. So we're going to look at 2 things on this. And whichever way works for you to help you remember it is the way that you should use. Okay, you can look at it as the rules this way. The product, so we're multiplying, 2 positive integers is positive. Okay. The product of 2 negative integers is positive. Okay. So if they're the same sign, you end up with a positive number. If you multiply a positive and a negative together, you get a negative. So if you have one of each sign. Now, I can't take credit for the next thing, but I love that this is a way to remember it. And for some people it works, and for some people it doesn't. Okay, again, I didn't come up with this, but it's a song that might help you, and it goes to the tune of Jingle Bells, and you're going to have to forgive my singing because it's not very good. Okay. But it also lines up with the rules. So when our rule says that a positive multiplied by a positive gives us a positive, okay, the first line of the song is pause, 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 saying that a positive times a positive gives us a positive. Okay, the product of 2 negative integers is positive, so a negative times a negative is positive. So in our song, neg, neg, pause. It says that rule. The product of a positive and a negative integer is negative, so if you have one of each. Okay, so in the song it says a negative times a positive is a negative. Neg, pos, neg. And then the last line is just that switched around. So in other words, these two last lines say the same thing. A positive times a negative gives us a negative. Pos, neg, neg. Okay, now I'm going to sing it through. Again, I apologize. To the tune of Jingle Bells. It goes pos, 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 neg, neg, pos, neg, pos, neg, pos, neg, neg. Okay, so let's try using that on just a couple examples here. Let's say that I have 5 times negative 6. Okay, well, I know that 5 times 6 is 30, and then I have a positive times a negative. Pos, neg, neg. Or I can use the rules. If I have one of each, I get a negative. Okay. Let's say that I have a negative 7 times a negative 3. I know that 7 times 3 is 21, and a negative times a negative, okay, or neg, neg, so I come up here, neg, neg, pos. It's a positive 21. Let's see here. Let's say we have a negative 8 times a positive 2. So I know 8 times 2 is 16. I look up to the song where it's pos, neg. I find pos, neg, neg, and the answer is a negative 16. So again, if the song works for you or if just the rules, okay. Now I caution you, if you decide to do the song, make sure that you remember it correctly, and also remember this only applies to multiplying. It does not apply to adding and subtracting, okay? All right, good luck with your assignment today, and make sure you get into the conference if you have any questions. Have a good day.